let's look at a couple of real-world problems. Exponential functions happen a lot in real life. And so the value of a car, y, and notice that this is in thousands of dollars, that's going to become important in a minute, that can be approximated by this model. Y is equal to 25 times 0.85 raised to the t power, where t is the number of years since the car was new. We first want to identify if this is growth or decay, and then what the annual percent increase or decrease is in the value of a car, and then finally estimate when the value of the car will be $8,000. So we want our value of our car, which is y, to be $8,000. And remember that y is in thousands of dollars, so this is actually a y value of 8, not 8,000. So let's be careful there. All right, let's identify whether we have growth or decay. So first we need to find our b value because that tells us. So we want to say that b is equal to, what's the number in parentheses? 0.85. And because that number in parentheses, 0.85, is less than 1, then that means that we have decay, which makes sense. Cars don't usually increase in value as they get older. So our b value of 0.85 is going to be equal to 1 minus r. Remember that we have subtraction there because we have decay. So r is equal to 0.15 or 15%. Remember, move the decimal place 2 times. So now we just want to figure out what t is when our value is $8,000 or a y value of 8. So we will find t when y equals 8. And so we want to basically just use Desmos or our calculator and find that value. So look at our table in Desmos or calculator. And so let's go there and take a look. Here we are in Desmos. I have my graph plotted, and now one thing I want you to notice is that I didn't put t as my exponent, I put in x. Desmos is going to get confused if you use something besides x as your independent variable, so just be sure you're aware of that. So I want to know what t is when my y value is 8. So I'm going to say that I'm going to either look at the table, and I'll show you that in a minute, but another little trick you can do is you can just do another graph at y equals 8, and then you can find the intersection, and you can see that it's at right about a value of 7. But if you wanted to, you could use the chart here. You could see just by looking at the graph that we're probably somewhere around, a value of 6, 7, 8, somewhere in there. So we could go in here and go ahead and put in some values and see where we are close to 8 for a y value. So 6 maybe, that's a little big, 7, and then 8. And you can see that an x value of 7 gives us a y value very close to 8. So we will go ahead and report that value. Again, you could get it off of the graph directly by plotting a line at y equals 8. So we will come back over here and report that our t at y equals 8 is about 7 years. So let's look at our next one. It says in 2000, the world population was about 6.09 billion. During the next 13 years, the world population increased by about 1.18% each year. Write an exponential growth model giving the population y in billions t years after 2000, and then estimate the year when the population was 7 billion. So let's take a look. Remember that our equation is y is equal to a times 1 plus r, we're in growth this time, to the t power. So we can simply plug in everything that we know. We know that our A value, our initial value, is 6.09. Our growth is going to be 1 plus our rate, and we know that our rate is 0.118. So think about moving your decimal 2 places, and that will be 0.0118. And then that's all raised to the t power. Let's go ahead and simplify that parentheses and say 6.09 times 1.0118 raised to the t. And now we want to know what year, how many years it was after 2000 when the population hit 7 billion. So we, again, want to know t when y is a 7. So we will find t when y equals 7. And so again, from our table in Calculator or Desmos, we will find out what that number is. All right, I've got my equation plotted. You can see that it's kind of flat, and we have to zoom out quite a bit in order to get a very steep turn in the graph. But we want to know when our population hits 7 million. So I'm going to zoom back in here, and I'm going to put in a y value of 7. So y equals 7, and we want to look for that intersection again, and it looks like it's at 11.87. So we'll call it 12 years just to use nice round numbers. Again, you could look at the table if you'd like. So our t value is 12, but remember that that is the number of years after the year 2000. So that means that we need to add 2000 plus 12, so the year will be 2012.